Hi, in this video we will see what type of problems can arise when we use linear regression model and least squares fit and how we can overcome them. So let's start with a simple example. So we will start with the example where we have lots of data. So we have 100 noisy measurements and we will want to fit a line into the data. So this means that we have two parameters to estimate, beta 0 and beta 1. And remember that we get the least squares fit by minimizing the residual sum of squares. Now, since we have a lot of data and only two parameters to estimate, this works well. But what if we have much less data? Now, here we have a model, which you can see by the black line, and we only make 5 noisy measurements. So this is quite a small amount of data. If we look at the red line, we notice that it fits the data well, so we have small bias. But if you look at the 3 red lines, you notice that they differ a lot depending on the measurements that we made. So we have high variance. And what you see here is overfitting. More generally, it might be that we have many unknown parameters, so it can be that the p is very large. And in that case, the assumption that n is much larger than p can be easily violated. So as we saw in the previous example, if the amount of data isn't significantly larger than the number of unknown parameters, then the least squares fit tends to overfit the data. And this leads to bad prediction accuracy. It can also be that we have more unknown parameters than data, and in that case, there actually is no unique least squares fit, and we can't use the method at all. We can still use the linear regression model, but we need to use another method to estimate the parameters. Here, we can use the regularization methods, which introduce a small bias, but they can reduce the variance significantly. And remember here the bias variance decomposition of the mean squared error. So a small increase in bias while the variance decreases significantly can lead to an improvement in the prediction accuracy. Another problem we might encounter is that we are using a very complex model, but many of the predictions aren't actually relevant predicting the response. Consider the model for predicting income of a person. So here we have 4 predictors: years of education, age, coffee consumption, and favorite ice cream flavor. Well, here the coffee consumption and the favorite ice cream flavor are probably quite irrelevant. But of course, in general, we don't know which predictors are relevant and which are not. So we would like to have a method that automatically picks those. So often some of the predictors in the model are not associated with the response. And including these irrelevant variables leads to unnecessary complexity in the model. Complex models are difficult to interpret, and if they are irrelevant predictors, we would like to get rid of them. Some regularization methods like lasso can be used for feature selection. This makes a smaller model by putting the sum of the predictors into 0, and this makes the model easier to interpret, and they also usually perform better. So thank you.